In this video, we're going to be talking about how to divide polynomials using synthetic division that I began in class on Tuesday. I only got like one example that I want to cover with you on that particular concept of dividing polynomials using synthetic division. And in class, I did give you a procedure for for dividing a polynomial using synthetic division. Now, this only works if your divisors of the form x minus some constant. Now, if it's x squared or x cubed in the divisor, then you'll have to use the long division process, which is thoroughly discussed in another video that I posted on Canvas in the LMS. In example 1, we divided 5x cubed minus 6x squared plus 3x plus 11 by x minus 2. And I took the x minus 2 and set it equal to 0 to find out what the divisor will be in the synthetic division process. And in this case here, your x is going to be equal to 2. So that 2 will be your divisor in the synthetic division. And in this case here, the 5x cubed minus 6x squared plus 3x plus 11, that's my dividend. So in this case here, I'll write down the numerical coefficients. There are no missing terms here. So here, for x cubed, it's going to be 5. For the x squared, negative 6. For the x's, 3. And your 11 is going to be your constant term. And in this case here, we brought down the leading coefficient in the bottom row, which is going to be the 5. And then I took my divisor, multiplied it by the number in that bottom row. So here 2 times 5 gave me 10. So the 10 went underneath the negative 6. And then if I add negative 6 and 10 together, you're going to get 4. And then I repeat this until all of the columns are filled. That's a series of multiplications and additions here. So in this case here, if I do 2 times 4, that's going to be 8. That 8 goes here. Add 3 and 8 together, you'll get 11. And then finally 2 times 11, that'll be 22. Add 11 and 22 together, you'll get 33. Okay? So now, to write the quotient and the remainder, the last number in the last row is always going to be the remainder. The quotient is going to be these numbers right here, the 5, the 4, and the 11. And the way I write the quotient is this. If 33 is my remainder, then for the quotient, it starts here. The 11 will be your constant term. Your x, the 4 will be the coefficient of x, and the 5 will be the coefficient of x squared. So here I'm going to have 5x squared plus 4x plus 11. And then plus, the remainder will be written over the divisor as 33 over x minus 2. Now, of course, in the homework, they're going to want the quotient and the remainder in separate answer boxes. Like for the quotient, they want, for this example, 5x squared plus 4x plus 11. And then for the remainder, it'll be 33, and not 33 over x minus 2. Now, in example 2, here we're going to divide x cubed minus 7x minus 6 by x plus 2. In that case here, there is a missing x squared term. Okay, so we need to compensate that with a 0 coefficient for your x squared. Okay, now what I did was put x cubed, x squared, x, and the constant, because I know I need a number there for each x term and the constant term itself. Now for the x plus 2, if I set that equal to 0, I'll have x equal to negative 2. That negative 2 will be the divisor for this particular division. Now for the x cubed, that coefficient is 1. I'm missing the x squared term, so I know I need a 0 coefficient for that. For the x is negative 7, the constant term will be negative 6. And then we do the synthetic division process by bringing the 1 down in the bottom row, and then I'll do negative 2 times 1, which is negative 2. Add 0 and negative 2 together, you'll get negative 2. And then do negative 2 times negative 2, that's going to give me this 4 right here. And then if I add negative 7 and 4 together, I'm going to get negative 3. And then finally, negative 2 times negative 3 will be 6. Negative 6 plus 6 will give me a 0 remainder. The last number in the last row is your remainder. And the 1, negative 2, and 3 are going to be your quotient. So 0 is my remainder, the 3 is the constant, the negative 3 is your constant term. The negative 2 will be the coefficient of x, the 1 will be the coefficient of x squared. So you're going to have 1x squared, or just x squared, minus 2x minus 3. And the quotient, you just type in x squared minus 2x minus 3. The remainder is 0, just type in the 0. Now notice I didn't do 0 over x plus 2 because 0 divided by x plus 2 is 0. Okay? So I won't need that. Okay, I had one more example of a synthetic division that I wanted to cover at the end of last class. So I'll go ahead and do that right now. Okay, here's example 3. Let's say I want to divide this 6x to the 5th minus 2x cubed plus 4x squared minus 3x plus 1. And that's going to be divided by x minus 2. Okay. Well, let's look at our dividend. There is, guess what? There is a missing term here. I got x to the 5th. But here I am missing a x to the 4th term. So if you want to, you can write this as 6x to the 5th. We're missing an x to the 4th term, so we need a 0 x to the 4th. Then minus 2x cubed plus 4x squared minus 3x plus 1. That's going to be divided by x minus 2. Now, my divisor says x minus 2. But if I'm going to use synthetic division, let me set that equal to 0 and find out what x is. If x minus 2 is equal to 0, then x will be equal to 2. That 2 will be your divisor for the synthetic division. Now, I'm going to write down my numerical coefficients from here. For x to the 5th is 6. For x to the 4th, that's 0. For the x cubed, negative 2. For the x squared will be 4. For x is negative 3. And then 1 will be your constant term. And notice I'm putting a small box here for the remainder. I want to separate the remainder from the quotient. Okay, so now, the first step would be to bring down the leading coefficient of 6. That goes in the bottom row. And now we're going to take that 2, which is my divisor, multiply it by 6. And that will give me the next number. If I multiply 2 times 6, I'm going to get 12. And if I add 0 and 12 together, I'm going to get 12. And then the next step would be to repeat this series of multiplications and additions here. I'm going to multiply the 2 times this 12 to get the next number. 2 times 12 then will be 24. Add negative 2 and 24 together, you're going to get 22. And then next, I'm going to take that 2, multiply it by this 22 right here. Take your divisor, multiply by the next number. 2 times 22 will be 44. that 44 goes underneath the 4. And add 4 and 44 together, you're going to get 48. Okay. And then next would be to multiply the divisor of 2 by this 48. 2 times the 48 will give me this next number of 96. Add negative 3 and 96 together, you're going to get 93. And then finally, we're going to multiply the 2. We're going to multiply this 2, the divisor, times that 93. That would give me the next number. 2 times 93 is 186. Add 1 to the 186, you're going to get 187. So this division process is finally complete. Okay, and finally, we're going to write down the quotient and remainder. That 187, which is the last number in the last row, represents the remainder. These other numbers here represent the quotient. Okay, so if that 187 is the remainder, I'm going to go from right to left. In this case here, the 93 will be your constant. The 48 will be the coefficient of x. The 22, coefficient of x squared. The 12 in front of that will be the coefficient of x cubed. The 6 will be the coefficient of x to the 4. So in this case here, the quotient and the remainder for this particular division problem will end up being 6x to the 4th plus 12x cubed plus 22x squared plus 48x plus 93 plus the remainder of 187 will be divided by x minus 2. Okay, so that would be the final answer to that particular problem. Now, in the homework, they're going to want this part right here. This part will be your quotient. And then the 187, you're going to key that in as just your remainder, not the 187 over x minus 2. I'm not writing it out like that because I don't have enough room on my sheet to do that. Okay. So that's how we divide polynomials here, using synthetic division. All right, the next thing we're going to do here is we're going to use synthetic division with this particular concept. And that concept there will be the remainder theorem. Now the remainder theorem states that if a polynomial called f of x is divided by x minus c, then the remainder is f of c. Okay? If we divide the polynomial f of x by x minus c, then whatever remainder that we get by that synthetic division process will be the value of the function at x equally to whatever that constant is. Okay? So let's look at a couple of examples of this. Let's say you're given this function, f of x is equal to x cubed minus 7x squared plus 5x minus 6. We're going to use synthetic division and the remainder theorem define f of 3. So here we're going to find the value of that function when x is equal to 3. Now, here we're going to use synthetic division. Now, our x is going to be equal to 3, so here we're just going to use that 3 as your divisor. Okay? Now, we won't use negative 3 because here your x value is already equal to something. X is equal to 3, so that 3, we just use that as your divisor. Now, in the f of x function, there are no missing terms here. We got x cubed, we got x squared, we got x, and a constant term, so we can write down the numerical coefficients here. So here, for x cubed is 1. For the x squared, -7. For the x, it'll be 5. The constant is -6. Notice I'm going to draw the box to separate the remainder from the quotient, but here we're not going to be dealing with the quotient here when we use the remainder theorem. Okay, so I'm going to bring down the leading coefficient, which is the 1, and that's going to go down in the bottom row. Now I'm going to multiply my divisor by that number in the bottom row. So if I do 3 times 1, that's going to be 3. And then if I add -7 and 3, I'm going to get -4. Then I'm going to repeat that process again. Do 3 times -4. That's -12. Now add 5 and -12 together, you're going to get -7. And then finally do 3 times -7, that would give me -21. And then add -6 and 21 together, I'm going to get -27. Okay? So now, the last number in the last row, which is at -27, that will be your remainder. And not only that, that particular value of -27, that's the value of this particular function when x is equal to 3. So we can say here that f of 3 will equal -27. Okay. So this is just another way of evaluating that particular function at some particular x value here. It's probably easier to do it that way than substituting each x with 3 in that function. Okay, you can do that and you'll see that you will end up with -27 as the final answer. Okay, that's example 4. Okay, example 5. Let's say we got f of x is equal to 3x cubed plus 4x squared minus 5x plus 3. And this time, we're going to use synthetic division and the remainder theorem to find f of -4. So we're going to be looking for the value of the function when x is equal to -4 using synthetic division. Okay, in this case here, your x is going to be -4, so your divisor there will be -4. Now, in this case, for f of x, there are no missing terms here. I do have x cubed, x squared, the x, and the constant term. So I can write their numerical coefficients here. For x cubed, that coefficient is 3. For x squared is 4. For the x, -5. And then 3 will be your constant term. And then I'm going to bring down the leading coefficient in the bottom row, which is going to be 3. And then I'll multiply the divisor of -4 times that number in the bottom row. So -4 times 3 would be negative 12. Now, if I add 4 and negative 12 together, I'm going to get negative 8. And then negative 4 times negative 8. That's 32. Negative 5 plus 32 would be 27. And then finally, negative 4 times 27. That's negative 108. 3 plus negative 108 would be negative 105. Okay. So as you can see here, the last number in the last row will be your remainder. Not only that, that is going to be the value of this function when x is equal to negative 4. So here, f of negative 4 will end up being negative 105. Okay. So that's how we apply the remainder theorem and synthetic division to come up with the value of any function at any given x value. All right, the last thing out of this particular section will be the factor theorem. As a factor theorem is going to help us find zeros of the polynomial function, and you'll be given that one of the numbers is a zero of that particular function. So here, the factor theorem states, if we let f of x be a polynomial, part A is this. If f of that constant c is equal to 0, then x minus that constant is a factor of the function f of x. And then part B is just a converse of part A. If x minus c is a factor of the function f of x, then we can say that f of c is equal to 0. So here parts A and parts A and B are just converses of each other. Okay? So in this example, number 6, and here I'm going to write all this out. Here we're going to find the zeros of 2x cubed minus 5x squared plus x plus 2 equal to 0. And let's say we're given that the number 2 is a 0 of the function, which is the same as this. F of x is equal to 2x cubed minus 5x squared plus x plus 2. Well, we're given that 2 is a 0 of the function. Since 2 is a 0 of the function, that would mean that f of 2 must be equal to 0. And according to the factor theorem, here x minus the constant will have to be the factor of f of x. So this means x minus that constant, which is your 2, is a factor of this function f of x. So we know one of the factors will be x minus 2. Now we need to find out what the other factor is going to be. Okay? that's where we use the synthetic division here. So in this case here, my 2 is going to be the divisor here, because here I'm going to use that 2 right there. In the f of x function, there are no missing terms here. We got x cubed, x squared, the x, and the constant. So I can write their numerical coefficients here. For the x cubed, it'll be 2. For the x squared, -5. For the x, it'll be 1. The constant term will be 2. So here I'm going to put down the leading coefficient of 2 in the bottom row. And then multiply the divisor of 2 times this number 2. 2 times 2 will give me 4. Put the 4 underneath the -5 and add -5 and 4 together, you'll get -1. And then 2 times -1 will be -2. Add 1 and -2 together, you're going to get -1. And then finally 2 times -1 will be -2. 2 plus a -2 will give me 0. I would expect to get a 0 there because 2 is a 0 of that particular function, okay? Now, the other factor is going to come from this quotient right here. Since the 0 is a remainder, this -1 has to be the constant term. And then the -1 in front will be the coefficient of x. This 2 in front will be the coefficient of x squared. Okay? Now, I'm going to rewrite this equation here. 2x cubed minus 5x squared plus x plus 2 equal to 0. That x minus 2 is a factor of the function f of x. So here, I get x minus 2 times, the other factor is right here. 2x squared minus 1x minus 1. I'm going to say 2x squared minus x minus 1 equal to 0. If you multiply all of this out, you would get this back. Now for the quadratic part, the 2x squared minus x minus 1, I can factor that out into 2 binomials here. I'm going to break 2x squared as 2x and x. Now for the factors of -1, it's going to be 1 and -1, but I have to put the 1 and the -1 in the right place. So if I put the plus 1 here and the minus 1 where the x is, -2x and a 1x will give me -1x. So factored completely, I get x minus 2 times 2x plus 1 times x minus 1 equal to 0. And then I'm going to set each binomial factor equal to 0. So I'm going to set x minus 2 equal to 0, and 2x plus 1 equal to 0, and x minus 1 equal to 0. Each one of these I'm going to solve for x. So for the x minus 2 equal to 0, if I add 2, you're going to get x is equal to 2. And then for the 2x plus 1 equals 0, subtract 1, you're going to get 2x is equal to -1. Then divide by 2, you'll get x is equal to -1/2. And then finally, x minus 1 equal to 0. If you add 1, you'll get x is equal to 1. Okay? So these are all the zeros of that particular polynomial function here. So the solution here would be 2, -1/2, and 1. These represent all the zeros of that particular polynomial function. Okay? So that's how we apply the factor theorem to that particular problem. Okay. I got one more of these examples here. Here we're going to find the zeros of this function, 15x cubed plus 14x squared minus 3x minus 2 equal to 0. And let's say we're given that negative 1 is a 0 of this function. F of x is equal to 15x cubed plus 14x squared minus 3x minus 2. That's the same as this right here, but it's just written as f of x. Now you're told that negative 1 is a 0 of that particular function. So in this case here, if negative 1 is a 0 of f of x, then that means we can say that f of 1 does equal to 0. Now if f of negative 1 equal to 0, according to the factor theorem, we can say x minus that constant, and that constant in this case would be negative 1, so I'm going to have x minus negative 1 or x plus 1, because minus a negative makes that a plus. So x plus 1 is a factor of the function f of x. Okay? So we know one of the factors is x plus 1. What's the other factor? That's where we use synthetic division. Here we're going to use that negative 1 as our divisor. Now in this f of x function here, there are no missing terms here. I do have x cubed, x squared, the x, and the constant. So here, the coefficient of x cubed will be 15. For the x squared, 14. For the x, negative 3. And then negative 2 as your constant term. And here we're going to use our synthetic division process here. So here we're going to bring down the 15, which is our leading coefficient in the bottom row, and then multiply negative 1 times 15, which is negative 15. And then add 14 and negative 15 together, you get negative 1. And then I'm going to multiply negative 1 times negative 1, that'll be a positive 1. Add 3 and negative 1 together, you'll get negative 2. And then finally, negative 1 times that negative 2 will be a positive 2. Negative 2 plus 2 is 0. I would expect to get a 0 remainder here. Okay? So now, the 15, negative 1, and 2 represents the other factor here. If that 0 is your remainder, then your negative 2 will be your constant term. Negative 1 is the coefficient of x. 15 is the coefficient of x squared. Now I'm going to rewrite this equation here. 15x cubed plus 14x squared minus 3x minus 2 is equal to 0. We've already established that x plus 1 is one of the factors here. And here's the other factor right there. 15x squared minus 1x, or just x, minus 2 equal to 0. Now that 15x squared minus x minus 2, I can factor that out into 2 binomials here. Now for the sake of time, I won't go into much detail on how to factor this out, but you're going to have to use factors like 3x and 5x for that. And the only factors in negative 2 will be negative 2 and 1. And I'm putting the plus 1 here and the minus 2 where the 5x is. That way, negative 6x plus 5x will give me a negative x as a middle term. So I got x plus 1 times 3x plus 1 times 5x minus 2 equal to 0. And I would suggest you check that playlist out for the factor that I posted under the announcement section on Canvas if you need help with factoring. And then set each binomial factor equal to 0. So I'm going to have x plus 1 equal to 0, 3x plus 1 equals 0. 5x minus 2 equal to 0. And then for each equation, I'm going to solve the x. So for the x plus 1 equal to 0, I get x equal negative 1. For the 3x plus 1 equals 0. Subtract 1, you get 3x equal negative 1. And then divide by 3, you'll get x equal negative 1/3. And then for the 5x minus 2 equal to 0, add 2, you're going to get 5x equal 2. Divide by 5, your x will be equal to 2/5. Okay. So these are all the zeros of that equation, or polynomial equation. Negative 1, negative 1/3, 2/5. Okay, so that's how we apply the factor theorem to these type of problems here. When you want to find the zeros of a polynomial equation and you're told what one of the zeros is. All right, so that concludes the rest of section 3.3, which is dividing polynomials and remainder factor theorems. Now, the homework will be available for you to complete on this particular section. And feel free to email me or call me if you have any questions about this particular section.